We have one problem related to mechanical energy, a word problem. We have a zero point 0.2 kilogram apple falls down. So we have a conservative force there in our system. We disregard friction. We never include friction here, only the gravitational force as the apple falls down at a speed of 3 meters per second from the tree. That is 2 meter tall. That's the height of the tree. Let's calculate ME, or the mechanical energy in this problem. The formula of our mechanical energy, it's very simple. It's the sum of KE, kinetic energy, plus potential energy. You can alternate this energy. You can have ME is equal to PE plus KE. You can have ME is equal to PE plus KE. It doesn't matter because it involves addition. Okay, so let's recall the formula of kinetic energy. It's 0.5 times mass times velocity squared plus our formula to get potential energy, mass times gravity times height. Gravity is 9.8 meter per second squared. It's constant as long as you are uh, on Earth. And the apple is probably on Earth. So we will be using the value of gravity, 9.8 meter per second squared, and the height. All right, so let's substitute our given. We have given here, we have the mass of the apple, that's 0.2 kilogram. We have velocity as it falls down, 3 meter per second. And we have the height of the apple tree, that's 2 meter. And of course, gravity on Earth, 9.8 meter per second squared. It's not in the problem, but yeah, it's understood that the gravity on Earth, it's 9.8 meter per second squared. Okay, so what's the mass? 0.5 times 0.2 kilogram multiplied 3 meters per second. That's the velocity. Don't forget to square it out. Plus mass of the apple, 0.2 kilogram times 9.8 meter per second squared. That's the gravity on Earth. And then the height. Height is 2 meters. All right. We will multiply all these magnitudes under kinetic energy. We will input it using our calculator. 0.5 times 0.2, okay, times, don't forget, we need to square the unit as well as the magnitude of this velocity value. Okay, so 0.5 times 0.2, 0.5 times 0.2, it's 0.1 kilogram. And then we will have to square the magnitude. 3 times 3, that's going to be 9. And then meter times meter, that's going to be meter squared. And then seconds times seconds, that's going to be second squared. So second squared. Okay. All right. Let's continue. We can definitely multiply all this stuff here. 0.2 times 9.8, it's 1.96 kilogram meter per second squared. Just multiply the unit. We still have 2 meters. We will multiply it by the height, 2 meters. So the answer will be 3.92 kilogram meter times meter. It's meter squared, second squared. Then this one, under kinetic energy, 9 times 0.1, it's gonna be 0.9, and the unit is kilogram meter squared second squared. Look at the unit. same unit, so we can definitely add these values together. So 0.9 plus 3.92, it's 4.82 kilogram meter squared per second squared, or again and again, kilogram meter squared per second squared, it's just 1 joule or J. So you can write it this way, 4.82 joules. That's the mechanical energy of our system here in problem A. Another problem, we have this illustration here. We have a ball rolls down from rest. So from rest, meaning velocity is 0 meter per second, it's resting, and we have our maximum potential energy there. It has a value. We will try to find out what's the maximum PE when the object is resting on top of this hill or mountain. The formula to get the potential energy is mgh. As we all know, the mass of the ball is 2 kilogram. And since it's happening on Earth, we have uh, Earth's gravity that is constant, 9.8 meter per second squared, so that you will not forget it. Okay, so we will put it in our equation, 9.8 meter per second squared, okay, multiplied by the height. Since the object is here and the height is 10 meters, we will plug all this stuff using our calculator. 2 times 9.8 times 10. The answer is 196. The unit will be kilogram meter squared per second squared, or we can write it down as 196 joules. This is the maximum uh, potential energy, and this is gonna be also our ME, right? Because ME is just the product of KE plus PE. And in this case, we don't have KE, it's 0 joule, but we have PE. The value of your PE, it's 196 joule. So this is going to be the value of ME. I hope it makes sense, okay? So we will proceed. As the object rolls down, it speeds up. Always remember, it speeds up when the object is falling down. It will gonna be speeding up, okay, with uniform acceleration due to gravity. It's always 9.8 meter per second squared. Anyway, if the ball is at this position, what will gonna be the let's say potential energy? Potential energy at 8 meter. For sure, as the height decreases, our potential energy will definitely decreases. So we will be expecting a lesser amount of joules, lesser than 196. Okay, formula, it's still mass times gravity times height. Mass of the ball, it's 2 kilogram, times gravity on Earth, it's constant, 9.8 meter per second squared, multiplied by the height. Our height is becoming lesser and lesser as it goes down, right? So we have 8 meter here. Plug this stuff to your calculator. 2 times 9.8 times 8. The answer is 156.8 kilogram meter squared second squared, or 156.8 joule. As you can see, it's getting lesser compared to 196 joules. Okay, and for sure it will be lesser than 156 if you will have to calculate the potential energy at 4 meters. Okay, you can pause this video and try it on your own. What's going to be the PE at 4 meters? Okay, so I will try to erase some stuff here. I will make a table and let's try to um, complete the table. So let's say we will still be using this illustration here, but this time we will need to complete the table. We have um, height here, and on the other side, we have ME, or mechanical energy. So let's say at 10 meters above the ground, KE is 0 joules. So our PE, we solved it already. Here is our answer. It's 196 joules. And that's going to be the maximum uh, mechanical energy. Okay. To get the mechanical energy, let's just, prove it. It's the sum of KE plus PE. KE is 0. So we will put 0 here, 0 joule. And then plus the value of PE, PE maximum, that's going to be 196 joules. So our mechanical energy is equivalent to 196 joules. As long as the force involved here is just the gravity. No friction, no other external forces involved. Okay, what if the object at 8 meter, okay, we calculated it a while ago, and we need to find the kinetic energy. What if we need to find the kinetic energy? Okay, as we all know, um, the PE at 8 meters, we will solve it again. It's 2 kilogram times 9.8 meter per second squared. That's the gravity, and then the height 8 meters. We have 156.8 joule. This is PE becoming lesser because the height is becoming lesser also. So our PE will also be uh, losing its stored energy, converting it into kinetic energy. So let's try to find out the kinetic energy. Okay, kinetic energy. How to find it? We will still be using the mechanical energy equation here. Your ME, we will be using the value of maximum mechanical energy, that's 196 joules. And then we don't have the value of KE, but we have the value of PE at 8 meters. So the value of KE at 8 meters, it's 156.8 joule. Next thing to do, we will retain KE in the right side of the equation, and we will transpose 156.8 to the other side. Positive will become negative. That's negative 156.8 joules. We will subtract mechanical energy, and the potential energy. 196 minus 156.8. The answer is 39.2 joules. So obviously that's gonna be the kinetic energy. Okay, kinetic energy when the object is moving at 8 meters. Okay, if we will, you know, go further, when the object is at 4 meters, what will gonna be its, let's say, potential energy? Potential energy um, at 4 meter, again, potential energy at 4 meters. So our formula will be mgh. The mass is the same, 2 kilograms. Gravity is constant on Earth, 9.8 meter per second squared. And the height now, it's 4 meters. Plug it on your calculator. 2 times 9.8 times 4. The answer is 78.4 joules at 4. What will be the kinetic energy here? We will be using the same method earlier. Mechanical energy is just the product of Ke and Pe. So Ke is unknown, but we have the value of Pe at 4 meters, that's 78.4 joules. And we have Me, it's constant since we have a conservative force here. Our Me will gonna be the maximum Me. So it's 196 joules. All right. So we will retain Ke and transpose 78.4 to the other side. Positive will become negative. So it's negative 78.4 joules. And then we will just subtract 78.4 from 196 joules. The answer is 117.6 joules. That's the Ke. I will compare the trend here. As we all know, as we decrease the height, I will make it bolder. As we decrease the height from 10 and then 8 and 4, look at what happened to the potential energy. It also decreases. So from 196, it becomes 156 and then becomes 78.4. Okay. On the other hand, um, the kinetic energy as the object falls or rolls down, it gains kinetic energy and it speeds up. Okay. For example, 196, that's the maximum mechanical energy. It's not the kinetic energy yet. It's the potential energy, right? It's resting. But once it begins moving, it started from where's the value? 39.2 joules, and then speeds up and it becomes 117.6 joules. So yeah, the velocity there is also increasing. Okay, increasing velocity as kinetic energy increases as it rolls down. One more proof that kinetic energy or the mechanical energy is equal in along the positions there, except here when it reaches the ground, everything will be zero, kinetic and potential. But before hitting the ground, what let's try to prove if the mechanical energy is still constant or conserved. Okay, just a proof. So the maximum Me in this position here, it's 196 joules. So the Me at 8 meters. So we need to know the KE and the PE there. We calculated it using this table. So at 8 meter, our PE is, what's the value? It's here. Maybe I will use another color. Okay, this is our PE value. So it's 156.8 joules. That's the value of PE. And what about the value of our kinetic energy at 8 meters? So we calculated it here at 8 meters. It's 39.2 joules. If we will add 39.2 plus 156.8, the answer will be 196 joules. That's the maximum mechanical energy. Okay, so it's just exchanging or converting from rest. We have a lot of potential energy. Once it moves, it it will be converted into kinetic energy. That conversion is the mechanical energy itself. So when the object is resting, it has mechanical energy because it has potential energy. When the object is running or moving, it still has mechanical energy because the object is moving. I hope it makes sense. Thank you so much. And if you're new to this channel, please subscribe if you like and give a thumbs up as well. Thank you.